Okay, so dear students, first of all, we are going to solve MCQs, paper 1 from dynamics from question number 88. Uh, the skaters of masses 80 kilogram and 40 kilogram move directly towards each other and collide. Before the collision, heavier skater is moving to the right with a speed 2 meters per second, and the lighter skater is moving this at the speed 1 meters per second to the left. You can make the situation heavier, like 80 kilogram, is moving to the right 2 meters per second. The lighter one, which is 40 kilograms, it is moving to the left at speed 1 meters per second. After collision, the heavier moves to the right. Wait a moment. Before collision, heavier was right, lighter was left. After collision, heavier moves to the right at this speed. So if heavier again moves to the right, okay, so you can say M1, M2, U1, U2, heavier, V1. So relative speed of separation you want. So first of all, you need to find final speed of skater, lighter skater. So principle of conservation of momentum we will apply here, my dear students. How do we apply? We say M1 U1 plus M2 U2 is M1 V1 plus M2 V2. M1 80. I will take the right side as positive, so the left side I will take negative. So U1 is 2, M2 40, U1 is negative 1, M1 80, V1 since it is right, so still positive 80, 0.8, M2 40 into V2 we will find. Let's rearrange this equation and get the answer. So left side is 80 times 2, 160 minus 40, 120. So left side is 120 is 64 plus 40 V2. So 64, 120 minus 64 is 56, is 40 V2. V2 is 1.4 meters per second. It came to be positive. It came to be positive. So my dear students, if you think what has happened after collision. So after collision, your V1, right side 0.8, V2 also positive, yani right side 1.4. I trained you whether you want relative speed of approach or you want relative speed of separation. If the bodies are moving in same direction, we subtract the speeds. So if you subtract 1.4 minus 0.8, answer is 0.6 meters per second, option A. So what do we do? Actually, most of the questions of dynamics which are involving momentum, we need to apply principle of conservation of momentum first to find the final velocity. Once you got the velocity, you can get the relative speed of separation by subtracting the speeds. How do I know they are moving in the same direction? Because they already told you the heavier particle is moving to the right, and right was positive. After applying the principle, the lighter also came positive, which is to the right side. So same direction, we subtract the speeds to get a relative speed of separation. Question number 89, my dear. Two balls X and Y approach each other along the same straight line and collide. The collision is perfectly elastic. So here it's a trick, my dear. If it is perfectly elastic, so relative speed of approach should be same as relative speed of separation. Relative speed of approach, if they move in opposite direction, you just add them. So ux plus uy. Relative speed of separation, they are also moving in opposite direction. We again add them, Vx plus Vy. So If it is perfectly elastic collision, we say relative speed of approach is equals to relative speed of separation. The answer is A. This was an easy question. Now let's go to the question number 90, my dear students. You know, principle of conservation of momentum is applicable on colliding particles, nuclear reactions and decays, plus the explosions. This one is explosion. It is a stationary firework. So stationary firework means total momentum before explosion is 0. So it means total momentum after explosion must also be 0. If total momentum after explosion is supposed to be 0, so you can also say momentums in opposite directions have to be equal. Momentums in opposite directions have to be equal. So you can resolute, my dear, not resolute velocities, you resolute momentum. X-axis, y-axis, you imagine. So you imagine x-axis, x-axis is 50, right? Can I keep in grams? Because all are in grams, right? So I will say 50 V2 cosine 60. Its y component will be 50 V2 sine 60. The left side also 50, but this is 50 V1 cosine 60. Up will be 50 V1, sorry, sine 60. Down is 100 times 8, 800. Now, my dear students, first of all, if you use left is equals to right. If you use left, right, 50 V1 cosine 60. 50 V2 cosine 60. 50 cancel. Cosine 60 cancel. This tells you that both speeds should be equal. Both speeds should be, they already gave in all options that they are equal. So it means we balance the y components. So total up should be total down. Total up, my dear, 50 V1 sine 60. 50 V2 sine 60. Down is 800. Yes, my dear? Now it's time to substitute V1 equals to V2 because they are both same. So both could be X. Both could be, let's assume X. So 50X, 50 times sine 60. And okay, I will take 50 sine 60 common. X plus X is 800. Yes or no? And then times 2. So 86.6 X is equals to 800. So 800 divided by 86.6, 9.2. So both speeds, they come to be 9.2. So what was the concept over here, my dear? The total momentum before explosion, since it was stationary. Stationary means total momentum was 0. So it means after collision, explosion, it should be 0. So 0 means the right side component should be left, upside component should be down. We equated them, we got the equation, and we solved. Answer came 9.2 for both of them. Option B. Question number 91. A bit different approach I will do. Okay, I told you multiple times that whenever there is an explosion, total initial momentum is 0. So total momentum after explosion 0. Mean opposite components should be equal. So I will not resolute. I will make this as x-axis and this as y-axis. Should I resolute? No need. They are already perpendicular to each other. The rule is opposite components should be equal. So you can assume that this is x-axis and this is y-axis. Yes. So I will say positive x is equals to negative x. So left side is what? 15 times v. The right side is what? 300 times 10 grams. Yeah. So V is equals to 3000 divided by 15. V is equals to 200. Option A. So this question didn't take much time, but your assumption should be very clear that the idea of resolution is two vectors should be at 90 degrees. They are already 90. They are already So just take one of them as x-axis and other as y. You can also try the y-axis. It will give you same answer. You want to try y-axis? Exactly same answer. So y-axis, I'm using red color. So 225 times 240 should be equals to 20 times 300. The problem is the y-axis has no unknown. Has no unknown. So it is giving you the same answers on both sides. So 6,000 is equals to 6,000. Did it give you something? No. So unknown was v. So v was on our assumed x-axis. We calculated, we equated, we got the answer. Next question. A rock of mass 2m is traveling in deep space at velocity v. It explodes into two parts of equal masses. Okay, very good idea. Just like before we did. So explodes mean total momentum before was zero. So after should be zero. Now this is something very interesting. If it was already stationary and they are exploding into two parts, yes. Now they say one of them is stationary. What is kinetic energy of moving part? So first of all, you know total momentum before explosion should be total momentum after explosion. The 2m was moving in deep space at speed v. One of them is stationary. So one mass is m times 0, other is m times v dash. Why I said m? Two equal masses, yani if total was 2m, if total was 2m, so each will be m. So 2mv is mv dash, m simplified. So v dash, the moving part speed is 2v. Speed is 2v. Now you want kinetic energy of this. So kinetic energy, my dear students, you know half mv square. And v is what? 2v. So half m 4v square. So 4 divided by 2, 2. So 2mv square is the answer. Option is D. Principle of conservation of momentum we applied. The rock was 2m, moving at speed v in deep space. So initial momentum was 2mv. After explosion, one is at rest, other is moving. So rest is 0, moving is m times v dash. We found the v dash and we substituted to find its kinetic energy. Make sense? Sure. Next question. Question number 93. An initially stationary firework explodes and splits into two fragments that move horizontally in opposite directions. The total kinetic energy transferred to the fragments by the explosion is E. Now, again, my dear, it's very interesting. Initially stationary, mean total momentum before explosion is 0, splits into two fragments that move horizontally in opposite. By the way, even examiner doesn't tell you that anything stationary explodes. They may not tell you. You should know they should move in opposite directions. Why? Because momentum before explosion is 0. So after explosion, the momentum must be 0. It can only be 0 if they are in opposite directions. Yeah. So if they are not opposite, they will never be added to 0. So total kinetic energy transferred to the fragments by the explosion is E. One fragment has mass m, other is 2m. What is the speed of the fragment of the mass m immediately after the explosion? Now the problem is you don't have speed of any of them. And initially it was stationary. Only you have, yeah, okay. So it means first you also need to deal with the kinetic energy as well as you need to do with the principle of conservation of momentum, both. Because you need the speed of the fragment of mass m immediately after the collision. So you need to have the relationship between their speeds. Okay, so can I say total momentum before explosion is total momentum after explosion, 0. So 1 is m, and for m, I will use speed v, okay? Plus negative 2m, I will use the speed v dash. Understanding or not? So problem is I need to know the relationship between them. Yeah. So I will do 0 is equals to mv minus 2mv dash. Yani 2mv dash is mv. So m simplified, v dash will be v by 2. This is a very trick. This tells you that after the mass m, its speed is v. Mass 2m, its speed is v by 2. You all agree? This is after collision. If you are able to fix this, your question is done. Now why? Because they say total energy was given how much? How much? E. So first m. You want for m or like what? Speed, you know. Okay. No, what is the speed? We need to relate the speeds with their masses. With their masses, that's the problem. So go for kinetic energy. So kinetic energy of, we are substituting any half for m, it is v square, yes? Plus half for 2m. For 2m, it is v by 2 square. Total kinetic energy was E. They told you. Yes? Understanding? Okay. Half m v square plus half 2m times v square over 4 is E. Yani half. Can I take mv square common? So it is half. This 2 cancelled. So 1 by 4, right? Is E. Half plus 1 by 4. 3 by 4. E. Cross multiply. mv square is 4e by 3. V square 4e by 3 m square root. Is there any option? Option D. You can guess how challenging could be dynamics from this question. Indirectly, actually, there is no deep concept. All is algebra. What did we apply? What we are applying in every question. First, we applied principle of conservation of momentum. We found V2 in terms of V. And then I say total energy. I substituted the velocities. One is V, other is V by 2. I kept rearranging and simplifying until I got V. 4E over 3M square root. The option is D. A genuine, a good algebra in this question. We applied 2 concepts. I hope you got it. Yeah? All is about simplification. Next question. Question number 94. A body initially at rest explodes into 2 masses, m1, m2, that move apart with speeds this. Already this is easier actually. This is only the first half. Just apply principle of conservation of momentum. TMBE is equals to what? TM, total momentum before explosion, is equals to total momentum after. Before it was rest. After explosion, the M1 goes with V1 plus negative. M2 goes with V2. Yeah, this is a very lower order of thinking. A few seconds. And you can solve this question within twinkle of an eye. So 0 is equals to M1 V1 minus M2 V2. Take to the other side, my dear. So M2 V2 is M1 V1. You want V1 over V2. You want V1 over V2. So it means you will bring V2 here and you can take M2 there. So the answer will be M2 over M1 is equals to V1 over V2. The right answer is B. That was an easy question. So far, all these questions, we are focusing, first thing, principle of conservation of momentum, and then we are talking about energies. Is there anything third over here? Now, we also need to now incorporate the next concept, which is impulse and forces with the momentum. Are you ready? After this, we have 2 hours, 1 hour, 1 hour.
So we won't work on 20 questions.
1 hour, 1 hour, inshallah. The ball of mass 0.10 kilogram is now explosion concepts. I hope you all understood, right? Now we are entering the impulse forces here. The ball of mass 0.1 kg is thrown towards a stationary vertical bat. The ball hits the bat with horizontal velocity 20. Okay, ball rebounds. So if it hits with the velocity 20, if you want to take this positive, so rebound, you will take what? Negative 15 meters per second. Okay, what is the change in momentum? Now, my dear students, please, I just encourage you all to follow the procedure. Many students, they come back to me, sir, mark scheme accepts if I do initial minus final. I'm teaching you very properly, always keep final minus initial. Why? Because whenever we need to deal with direction, initial minus final will give you wrong direction. Final minus initial will give you correct directions in case if they want. So please keep that protocol. So change in momentum is also called impulse, which is m v minus u. Now mass is 0.10, v is negative 15, minus u is 20. The answer is 3.5 Newton seconds negative. Since magnitude is 3.5, yeah, in case if they ask you the direction, so negative is helping you, the direction is to the left side. You understanding? Okay, so please keep rating the questions, Yani. So far, we did 2 questions very challenging, but this was a very simple question, yeah? This one, impulse one. If you are careful about the signs, please keep rating the questions. Question number 96. Sphere X and Y from an isolated system. Okay, isolated system means no external forces acting on them. Mass of Y is greater than mass of X. Okay, sphere Y is stationary. X collides elastically with Y. Okay, Y stationary mean its speed was no matter but 0. X, it has a speed. Okay, they say the mass of Y is more. So this mass of Y, anywhere I'm writing, is more than X. Okay, X collides elastically, and it collides elastically mean 2 things, you know. Number 1, relative speed of approach is equal to relative speed of. Number 2, total kinetic energy of both of them before collision, which is actually the total kinetic energy of X, is equals to total kinetic energy of both of them after collision. Okay, so the speed of sphere X before collision was u. So it means total kinetic energy of before momentum was before collision was only for X. Which statement must be correct? Let's see. Sphere X rebounds with a speed that is greater than u, and Y moves off with a speed less than u. First of all, it is not possible. Why? Relative speed of approach is u. Option A is saying that it rebounds with greater than u. Choose anything greater than u. To you, no, greater than u. To you, no problem. And this goes less than u. Choose anything less than u. Half u. Imagine. So in opposite direction, you will add them. So if you add 2u plus 0.5u, it becomes 2.5u. Yani it becomes more than speed of approach. Option A is wrong. Did you understand? Okay. Sphere X rebounds with a speed which is less than u. Sphere Y moves off with a speed also less than u. This may be correct. It may be correct. Why? Because they both, yani, both are less. If you add, they may be u. So let's read the other options. X rebounds with u. Y is the stationary. Now this looks correct. This Looks correct, but this is 100% wrong. Why it looks correct? Because the relative speed of separation is u. Why it is wrong, I will tell you why. Because total momentum before collision was m into u. If you use c, total momentum after collision will be m into negative u, which is negative mu. Is this same? No. Here. So if not same, c is wrong. Relative speed of separation is still u. But the problem is if x rebounds, what does that mean? If x rebounds, what does that mean? It means the final momentum is opposite direction, in negative u, which is wrong. Okay, D. Sphere x remains stationary. Okay. Y moves with a speed which is less than u. Now, this may also be right. Why? That's why I did not choose option B for you. I did not choose. Now, why? They say x remains stationary. Why? Maybe x is 0, so less than u because mass is more. So speed is less. So maybe it is also correct. Momentum m into u, since u is less, mass is more, so it may be equals to. Now we are stuck between option B and D. Now the idea is something else, my dear. When a light object hits the heavy target, there are only two options. Either the target will stay stationary and the light will rebound, or the target starts moving forward, X rebounds. It is not possible that the light object hits the heavy object and both starts moving in same direction if it is stationary, because mass was more. Now one concept I gave you, the two options is, yani light have to rebound. If light particle collides with the heavier particle at rest, the light have to rebound. Light have to. Now, sphere X rebounds with a speed which is less than u. Okay, look. We need to just understand if it is right or no. Yeah. This is what I'm saying, that it might be wrong. I'm giving you another approach. The other approach is, that's true. That is a rule, actually. You can write it. That if a light particle collides stationary heavy particle, light rebounds. Yes, light rebounds. Looks like B. Now, the other thing is principle of conservation of momentum as well. Yeah, principle of conservation of momentum, my dear. Principle of conservation of momentum, if you apply to the last one, it is also correct. If you apply to the first B, it is also correct. Principle. Why? Because the one which rebounds, it has less speed. Also the less momentum. And to the left side, the target cannot, okay, and speed, Y moves off with a speed which is also less than U. Yes? Now the total momentum, what? Total momentum, if you apply, ideally the total momentum of Y must be more than total momentum of X, so that the total momentum is positive. Is that positive? Sphere D, X remains stationary, Y moves off with a speed. It cannot be stationary if you apply this concept. Every other point is valid here. But this point is not valid for option D. Option D has every other information right. Other than the light particle, when it sticks, it cannot stop and cause the target to start moving. Just imagine a small car hits a heavy, large stationary truck. Do you think it's possible the car will stop and truck will start moving forward? No. That's it. Question number 97. A very easy question. This question should be solved within twinkle of an eye. Two satellites in a deep space collide inelastically. Khalas, total momentum is always conserved. Inelastic means kinetic energy is not conserved. So option is C. I told you that this question could be solved in a twinkle of an eye. This was easy. Question number 98. We will start paper 1 after 1 hour. Yeah. So what is a reasonable estimate of momentum of a family car with 25 km/h speed? Estimates in chapter 1, I told you, the family car mass you can take from like round about 2000, from 1500 till 2000. So I'm taking the mass as 2000. Yani, just for your information, my car, its mass is 3200 kilograms. I'm just telling you. It's also a family car. His car is small. So, yani, on average, I wrote a mass for you. This kilometer per hour. The problem is kilometer per hour. When you want to change kilometer per hour into meters per second, so conversion factor is 3.6. You can do directly. Yani, you can directly divide by 3.6. If you don't like this, there is another way. 25 kilometer mean times 1000 per hour mean 3600. It's the same answer. So 25 divided by 3.6, the speed is 6.94, okay, meters per second. So momentum is mass times velocity, 2000 times 6.94. Give me answer. We will say which one is closest to that. Sorry? 13,888, which is 1.4 into 10 power. How much? 4. By the way, very crucial. Yani. But it's obviously there is only option which is close to this is 1.4 into 10 power 4, yani 8. So it's estimate. So estimate, yani you assume a number in your brain. Yeah, that's it. Question number 100. A ball collides with the wall. Before the collision, it moves with a velocity 8 meters per second. Again, to the right. After collision, to the left. This question, again, you can solve in a same idea, in a twinkle of an eye. So you have a change in velocity you want. So change in velocity means delta V. Now I told you change is always final minus initial. Final is -3 minus initial is 8. Answer is -11. Answer is 11. Negative, what did you assume? Negative you assume to the left side. You got it? So since you assumed negative to the left side, so there are all questions are not that hard. Some are really very easy questions. 101. A lead pellet is shot vertically upwards into a clay block that is stationary at the moment of impact, but is able to rise freely after impact. Okay. Mass of pellet is 5 grams and the mass of the clay block is 95 grams. Pellet hits the block with an initial velocity 200 meters per second. It embeds itself. Just like it coalesces. They join together. So if they join together, what will happen? M1? Wait a moment. It's a very long question. M1, U1, M2, U2, M1 plus M2 into V. First, we will see at what velocity they both start to move together. Can I just keep grams, all of them? Yeah. So 5, 200, 95, 0, 5 plus 95, V. 1000, 100 V. V is equals to 10 meters per second. So this is combined velocity, they start to move. Now momentum done. Now let's go to kinematics. Very good, excellent. So step 1 was to apply momentum. Now I will go for kinematics. So initial speed, now joined particles, the joined one. Initial speed is 10. 10. Acceleration going up, negative 9.81. How high above it can go? Maximum height, final speed is 0. How high? S is question mark. Kinematics. V square is equals to U square plus 2AS. V square is equals to U square plus 2S. Let's substitute the values, my dear. Find maximum height speed 0. Initial speed, they started to move at 10. Acceleration is negative 9.81. S, we want to find. So S, when you rearrange, it is 10 square over 2 times 9.81, which is 5.1. Is that A? Okay, this was multi-step question, but solvable.
Or you can also solve it by kinetic energy to gravitation potential, right?
You can do that. But still you need to do the step 1.
Yeah.
Correct. Make sense? 102. A block is moving on a horizontal frictionless surface, a constant force F, and a constant resistive force 5 Newton acts on it. Okay, we are done with the impulse collisions. This is the forces and momentum mixed. So forward force, I mean F, resistive force 5 Newton. Graph is this. Please keep in your mind, no matter what, every graph has 2 useful features. It could be a gradient, it could be area under the graph. If you look at this graph, the y-axis is change in momentum, x-axis is time. You know that rate of change in momentum is called force. Which force? Resultant force. How do we state the Newton's second law of motion? The resultant force is proportional to rate of change in momentum. Do we say force? No. So if you don't focus on the word resultant, you may do the mistake. Then graph will be used to find F. Yeah. So let's go to graph first, as I told you. So the graph, its a gradient is actually the resultant force. Gradient is the resultant force, which is rate of change in momentum. So gradient is 2 point. It's actually negative is the gradient, yes? So negative 2.7 over 0.4, which is sorry? Oh, it's 1.5, yeah, sorry. Then do the points way. Yalla. So first point is 0, 2.7. And the second point is 0.4, 1.5. Y2 minus Y1, 2.7 minus 1.5 over 0 minus 0.4. So gradient is negative? Negative 3. So actually resultant force negative 3. What does that mean? It is to the left side. So if resultant force is negative 3, it means friction is more than the forward force. It means the body is decelerating. Yes, speed is decreasing. Speed is decreasing. So now you can do that. So usually I taught you the resultant force is forward minus backward. Yes? So what is resultant force? Negative 3. Forward, we don't know. Backward is 5. So negative 3 plus 5 is forward force, which is 2 newtons. You can cross-check by reverse solving. Yani if your answer came 2, so it means forward is 2, backward is 5. So resultant will be what? 5 minus 2? 3 Newton. Yes, we are right. Okay, which statement about perfectly elastic collision is correct? Before you choose anything, decide in your brain 2 points. Total kinetic energy is conserved. Number 2, relative speed of approach is equals to relative speed of separation. Total kinetic energy is conserved? Yes. Relative speed of approach is equals to relative speed of separation. How about this sentence? It's a perfect sentence. Let's see what is the drawback in B, C, D. Total kinetic energy is conserved? Yes. Relative speed is not equal. Wrong. Not equal. Wrong. Energy is not conserved. Wrong. Option A. So such questions we can solve within twinkle of an eye. 104. Which of the following is a statement of principle of conservation of momentum? My dear students, I don't want to argue with you later. Sir, why not this? Why not this? Don't read the option. For any isolated system, total linear momentum is always conserved. That's it. Nothing else. It could be a right statement, but not a principle of conservation of momentum. So, momentum is product of mass and velocity. This is not the principle of conservation of momentum. Elastic collision momentum is constant. Whether it is elastic or inelastic, momentum has to be constant. It is not the principle. The momentum of isolated system is constant. Yes. Isolated system, the total momentum is constant. Force acting on a body is proportional to rate of change in momentum. It's a very good sentence, but it is Newton's second law of motion. This is second law of motion. Principle of conservation of momentum. Total momentum of an isolated system is always constant. I will play. 105. A molecule M is traveling horizontally with the velocity u. Please use my way. My way is the best way in the history of mankind to solve physics. It is moving the mass M with a speed u. It rebounds with a speed u again. Now, my dear student, if this one is positive, this is negative. Using my way, the M final minus initial M into negative 2V, which is negative 2mu. Option C. D. I say C, yani show. Again, this question is as easy as to breathe underwater. For fish, collide elastically. Excellent, my dear. So RSA, relative speed of approach. My dear students, my dear sisters and brothers, when the bodies move in opposite direction, whenever the objects they move in opposite directions, their speeds are to be added. So you will add the speeds. It will be ux plus uy. And when they move in separate apart after, they are still moving in opposite direction. It means relative speeds, approach and separation must be equal. So this was opposite direction, ux plus uy. These are also opposite direction, relative speed of separation, vx plus vy. Since they are moving in opposite direction and we added the speeds, so relative speed of approach is equal to relative speed of separation. The answer is A. 107. Understanding? I give you all total 17 seconds to absorb this information. Both X and Y. Next. Dear students, please use my method, the one which I made. So using my method, if initial speed V is to the right side, if you take positive. So they say perfectly elastic collision. So at the relative speed of approach was V. So relative speed of separation should also be V. Yes or no? but I will take negative sign, yeah? So change in momentum, my dear. M final minus initial M negative 2V, which is negative 2 MV. Now, MV is the answer. Negative tells you what? Left side. Left side. I think you are confused. Initially was from left, yani to the right. So answer is 2 MV to the left side. B. Make sense? Sure? Akid? 108. Which statement is principle of conservation of momentum? Total linear momentum of an isolated system is constant. Force is equal to rate of change in momentum. This is second law. Perfectly elastic collision, relative speed of this is elastic collision. We don't want. We want principle of conservation of momentum. The momentum is product of mass and velocity. It is not the principle. It is definition of momentum. So total momentum of a system of interacting bodies remain constant provided no external force. No external force means isolated system. So total linear momentum of any isolated system always remains constant provided no external force acting on it. Yeah. Next question. Okay, 7:10, I will stop this. 5 minutes stop and then paper 2. Question number 109. The diagram shows two identical spheres, X and Y. Initially, X moves with the speed V directly towards Y. Okay, you can see. Y is stationary. The spheres collide elastically. Elastically mean, okay, relative speed of approach and separation should be equal, plus momentum should be equal. If I go for relative speed, RSA, it is V minus 0, which is V. So RSS should also be V. Let's check. Half V to the right, half V to the right. So relative speed will be 0. Option A is wrong. Same side, we subtract the speeds. V to the left, stationary. The relative speed will be V minus 0, V. Mumkin, but I don't think so it is right. Moves half V to the left, half V to the right. Half V minus, add half V is equals to V. Also possible. Also stops V to the right. 0 plus V, V. Also possible. So if you are not able to decide which one is right, wrong, principle of conservation of momentum. Total momentum before collision. Okay, they are identical, right? Can I take them as 1? No problem. Or M? Okay, M. Before was M times V plus 0. MV is the momentum. Now let's check B, C, D. For B, V to the left, yani M times negative V plus 0, negative MV. Is this same? No. Momentum is not same. Before collision, momentum was plus MV. Before collision, momentum was plus MV. In B, after collision, momentum is a negative MV. Okay, can I check C here? C. X moves to the left. Yani X moves M times, negative M times half V. Y moves to the right, plus M times half V, which is equals to 0. C is also wrong. C is also wrong. Why momentum is not conserved? Let's check D. D stops, yani 0. Plus that moves with the speed to the right, V is MV. So momentum is also conserved. Relative speeds are also equal. Option D, a good question. I give you 26.4 seconds to absorb this information. Be serious. No.
You.
It is MOT, medium order of thinking.
Can you solve the question?
We will solve, please. Let me continue with these. It was 46.
What's that?
It was 46 when you came. Actually, but Ahmed is 21.
I like that.
No, Muhammad Ahmed.
It's literally.
Very well. Okay. Next, my dear. This question number 110, the diagram shows the cannonball fired from a cannon. The mass of the cannon is 100 kilograms, 1,000 kilograms. Mass of the ball is 10 kilograms. Recoil velocity of cannon, the backside, 5 meters per second. What's the horizontal velocity of the ball? We don't know. Okay, we know that Tumbuf is equals to TMAF. Total momentum before firing is equals to total momentum after firing. Before firing was 0 because it was stationary. After firing, okay, if you take the right side as positive, the left you will take negative. So 1,000 times 5 plus negative 10 times V. Negative means opposite direction. So 10V is equals to 5,000. V is equals to 5,000 over 10. How much? 500. Total momentum before firing is equals to total momentum after firing. Next question.
So,
Keep talking. A block of mass 0.6 kilogram is on a rough horizontal surface. A force of 12 Newton is applied and it accelerates 4 meters per second square. Okay, what's the magnitude of frictional force? We say MA is equals to forward force minus backward force. Mass is 0.6. Acceleration is 4. Forward is 12. Backward, we don't know. 2.4 is 12 minus x. X is 12 minus 2.4. 9.6.
so
Next question.
because what is
Question number 112. Two spheres approach each other along the same straight line. Their speeds are u1, u2 before collision, v1, v2 after collision, if it is perfectly elastic. If they are moving in opposite directions, we add them. This is relative speed of approach. If they move in same direction, relative speed of separation, we subtract them, v2 minus v1. So u1 plus u2 should be equals to v2 minus v1. Option D. Option D, my dear. D. It's wrong. It's wrong. Where's your attention? Sorry. When you will talk, I'll not go back. Question number 113. Which statement about the ball that strikes the tennis racket is always correct? The total momentum of system. System is constant means what? So the tennis racket plus the tennis ball, the total momentum should be constant. Option D. Yeah, this question we can just solve within twinkle of an eye. Yeah, this question is one of the best questions so far we are solving. The diagram shows two spherical masses approaching each other head-on at an equal speed u. One of them has mass 2m and the other one has mass m. In which diagram showing the situation after the collision shows the result of an elastic collision? First of all, there are two rules we need to apply. The total momentum before collision should be total momentum after collision. So before is, if you take right as positive, left as negative, so 2mu plus negative mu. So total momentum before collision was mu. And relative speed of approach is, since they are moving in opposite direction, u plus u is 2u. Okay, first of all, you can shortlist in which relative speed is 2u. And then if you have more than one options, apply the principle of conservation of momentum. They are moving they are moving in opposite direction. So relative speed will be u by 3 plus 5u by 3, which is 2u. This may be right option. The next one also opposite direction, u by 6 plus 2u by 3. Yes, if you add them, it is 5u by 6. Relative speed of separation is not same. My dear students, these two are moving in same direction. When they move in same direction, we subtract them. Forward, yani this minus u by 6. If you subtract them, it is half u. Also not same. The last one, they coalesce. When they coalesce, it's not elastic collision. So option is A, my dear. Alhamdulillah, sorry. Oh, okay. Maybe if more than one option, they both have same relative speed of separation. Then we will try to find total momentum after collision. Huh? We used already in a table question a while ago. We didn't use. In this question, we did not use. Okay. The last question of MCQs is, two experiments are carried out using two trolleys of equal mass. All moving parts of the trolleys are frictionless. As frictionless means no external force. No external force means it is an isolated system. Okay, so as the surface, as is the surface that the trolleys move over. In the both experiments, the trolley X moves towards trolley Y, which is initially at rest. After collision in experiment 1, X is stationary, Y moves off. After experiment in 2, the trolleys, they join together. First of all, I told you, whenever they join together, it is always inelastic. I told you very clearly during my explanation session. Why? Because they move together, relative speed of separation is 0. But there is already relative speed of approach. They are not equal. So experiment 2 is inelastic. Experiment number 1, elastic. Why elastic? Let's check. Because this was stationary, this was moving, yes, and it has momentum mv. After collision, after will be, this will be stationary, this will be moving, because they are saying the experiments trolleys have equal masses. Yeah? Yes or no? It's written in the question. Sorry? No, they say that X stationary, so Y moves off. You want to know that how we know same velocity? Father, mv plus 0 is 0 plus mv dash. So mv is equals to mv dash. So velocity is also same. Velocity is it? No, it's a valid question. He says, how do I know the velocity is also same? So this is elastic collision. Right option is B.